Okay, so we've got our equations. We're going to graph them. I'm going to give you some graph paper and get you going on that right now. I just like to shade a little bit in the direction that I'm going to be going because it said less than or equal to 6. All right, the next one is x is greater than or equal to 0. That means I go along here. No, that's not x, that's y. But that's okay. I'm going to have to do that one eventually anyway. And shade above that one. And then x is greater than or equal to 0, which is this one. And it's a little bit on this side of the line. Okay, and then the hardest one, which is this one right here, I'm going to start at 10.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5 is right there. And I'm going to go down to, if I use a slope of -1/2, that means I'm going to go down 1 and over 2 for each one. And I'm going to have to do that 10.5 times, which means I'm going to have to go over a total of 21. So I'm going to go down over here to 21. 1, 2, 3, 4, 5, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I'll just have to kind of cheat and go over there and connect those two lines. I just missed this one. I'm going to say that I made it just to make it easier. And this one, by the way, I shade just underneath. Then my feasible region, the places where they all shade to, it's like that. Okay, so here's the possibilities. My veterinarian's office, remember that's what this is about, can do any of those combos, but one of them will make them the most income. Now this is the new stuff now for today, is optimizing their income. We've got to write an equation for that. So I'm going to go back to the original problem here and see if we can find the original problem. That's not it. There it is. And write the optimization equation for it. Remember the thing we didn't do before because we were going to leave it for later? Which part didn't we do? The money. So let's do the money now. Well, we get $55 for each office visit. So how do I write that in math? In mathese. 55 for each office visit. Well, each office visit was an X, right? So 55 for each X. Anytime you say for each, that means like times by. And then surgeries are 125 for each Y. And when I multiply that all out, they didn't tell me like I want to make this much profit. Otherwise I'd say equals that. But they just tell me that that's how I make my profit. So I say profit. Actually, technically it's income, but I'll say it's profit. All right, so there's my little equation that I need to optimize. Now, I'm going to put that back to this other screen over here. That was 55 for each X plus 125 for each Y will give me my, fine, I'll say income, even though technically I think the profit, they wanted profit, but it's not the same thing really. All right, so next I got to test points, but I want to be smart about it. I could have to test all 4 of these points. I'm going to call them A, B, C, and D. A, B, C, and D. Can you tell me one I can eliminate is not going to have the most profit? Yes. A, 0, 0. No way you're going to make a lot of profit when you do nothing, right? So it can't be A. And between B and C, can you give me a logical argument why you know one is better than the other? Why is C better? Yes. Yeah, you're going to be doing more. More of what? Your Y stays the same, but more of X. More of those checkups or office visits. This has the same height, the same Y, and therefore the same number of surgeries, which are on this axis. And this one here goes out farther. And so therefore, I'm going to go straight down here. I would do a lot more, I'd make a lot more money at C than I would at B. So then between these two, it's hard to tell. whether it's going to be this one or that one. So I'm going to write down the 2 points. This one is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 10? 1, 2, 3, 4, 5, 6, 7, 8, 10, comma 1, 2, 3, 4, 5, 6. 10, comma 6. This one's at 21, comma 0. And here's how you finish this. I need your full attention. This needs to be stuck into my equation and get an answer. And this needs to be stuck into the equation and get another answer. And whichever one gives me the most profit wins. All right, so 10 comma 6. I'm going to stick in a 10 and a 6. So 55 times 10 plus 125 times 6 equals some amount of profit. Somebody figure that one out. And a different person, would you figure out the one where it's 55 times 21 plus 125 times 0? That's easier. Okay, who's got the first one? Yes. What is it? 1300? Okay. And the second one? Yes. 1155. Now you might say, well, the difference, it's pretty close, but if that's $145 per day difference, you think that's going to add up? Let's figure it out quick. At the $145 a day, times that by 5. Everybody grab your calculators if you haven't already. You'll need them for the homework. 145 times 5. How much a week is that? Okay, times that by 52 weeks in the year. $37,000 your vet clinic is going to make more if they do the right combo. Okay, so you can see it can make a difference in the real world. This is all numbers that were fairly close to accurate, except for the fact that surgeries actually cost more in the real world than what we had on this. But the number of hours in the day is about right, etc. Okay. Now remember, that was your total income for the office. You don't make all the money that comes in income is not profit, it's income. All right. Now your homework is going to be, you're going to make the chart like that for each one that tells your max profit. This is a different problem, but that one's got more profit, so that one wins. That kind of thing is necessary for today. And here is the first problem of today's homework. So I'm going to pause while I hand those out, and then I'll do it a little bit with you. Okay, the things I've underlined here, as we just read through the problem together, are the 3 things that I can use to write equations. You know, the $8 an hour and the $10 an hour, why aren't those going to be graphed? Because those are going to be in the objective function. And so you don't include those on the graph. The graph is X is the hours she works at the Academic Support Center, which, by the way, is the tutoring. And the Y is the restaurant one. And there's no mention of money at all. So don't mess with the money. Don't write an equation for the money until you get to the objective function thing. All right. So identifying the 4 constraints. Number of hours she wants to tutor. That's the green line and the blue line. See if you can write those 2 equations. Okay, it's talking about tutoring. So which variable should I use? X. And it has to be no less than 2. Sounds like they have some minimums. They want you to make it less than, or could it be equal to? Yes, 2. And it has to be no more than, wait a minute, I think I did that wrong. Yeah, I have that backwards. It's got to be bigger than or equal to 2 and less than or equal to 8. So that's 2 equations. Next, hours she can work at the local restaurant. And then it says common sense constraint, because I didn't see anything in there that said you got to work this number of hours at the restaurant. So you just use common sense. What in the real world limits us? Time. What about time? Has to be more than 0. So the amount of time can't be less than 0 anyway. So the time she works at this place, at the restaurant, sorry, that's Y, has to be greater than or equal to 0. That's the equation I'm looking for there. And there's our last constraint, x plus y is less than or equal to 20.